we're going to go ahead and move on to inequalities today. Okay, yesterday we did equations, and they're not too terrible. Inequalities work and act a little. Solving inequalities is like solving equations, but with one little twist. Okay, I'm going to add one more thing every day. It's going to be like, oh, that's easy, and before you know it, one more thing, and it becomes a whole lot of things. So it's good to try to keep up. That's the problem with math. If you miss like 3 days, you come back, it starts to pile up on you, right? So that's why I think the videos are good. Okay. The inequality means greater than or less than, or greater than or equal to, less than or equal to. It means, so if I wanted all the numbers that were less than 5, give me a number that is less than 5. 4. What about another number? 3, 2, I heard. 1, 0, -7, negative everything is less than 5, right? There's a whole lot of numbers less than 5. Okay? Is 5 less than 5? No, it's not. 5 is not less than 5. Is 4.9 less than 5? Yes. 4.999. Yes, okay? So there's a lot of numbers, and y'all didn't want to go decimals, and like 2/3 is less than 5. There's a lot of numbers that are less than 5, okay? So we could be here all day. I got better things to do than rattle off numbers. So as a visual kind of guy, I like to draw it on a number line. So how do we represent, anybody remember how to represent all the numbers that are less than 5 on a number line? Mm-hmm. Yeah, we're going to take all these numbers that are below 5 and shade over them. If you like your crayons, this is a good time. But when it's like this, we represent the fact that we get really close to 5, because I said 4.9. Now, I draw big. When I graph, I try to draw big because I'm not the greatest drawer. And I can actually, I'm going to do it with a crayon because I like crayons. You don't have to use crayons for it, but anytime I can use a crayon as a 46-year-old man, I'm going to. Okay? I'm 46. I'm like old and stuff. I don't know what old is, but some days I feel it, but I don't think, I don't act it all the time. Okay? Thank you. So anyway, when it's less than or greater than, we use, like Lauren said, an open circle or a circle not shaded in. But in the second one, x is greater than or equal to. How is that one different? How do we, because 3 is greater than or equal to 3. Okay, 5 is not less than 5, but 4.9 is less than 5. So I want to get close to 5, but not at 5. So how do I get to 3? I have to take that circle and shade it in. Okay, so I would go to -3. And instead of doing an open circle like I did on the first problem, I would color it in, fill it in. And I tend to over-exaggerate when I do this so that because usually you draw your line in pencil and then you do your shading in pencil, right? And it's hard, it's hard to see. So another way you could do it, I'll sometimes draw my shading. Anybody ever do that to kind of make it easy to see? I just draw it above the line. I don't care. You can sit there and color if you want to take a long time, but somehow make it stand out. If I can't tell, if you do this, now it's actually okay on the board because you get a little bit, but if you do this, you're making my life hard, okay? I did get new glasses this summer, but don't make my life hard. You make my life easy, I'll be happy. So that's why make sure, and I don't want to be confused, so I make sure the circle's filled in, and if you want to do it in a different color, by all means, feel free to be colorful. Obviously I like bright colors, and a little bit of flair, but I also don't want to spend half an hour shading in a line either, okay? So, fair enough. Okay, what about x, negative 6 is less than or equal to x? This is when people start getting a little confused. It's kind of still the same thing, but what's different about the third problem on the board? Yeah, they flipped it. Okay, so you have to really kind of think a little bit. Be careful, because I'm gonna screw with your head at times if I can. Okay, I'm gonna change things around a little bit. How would I start? How would we start this third problem? I'm going to mark it 6. Is it going to be filled in or open circle? Filled in. This is going to be filled in at 6. I'm sorry, negative 6. Okay? So I'm going to go to negative 6. I'm going to do it in blue, purple. That's what I said. Purple is actually my favorite color. All right, now how do I decide whether my arrow is pointing to the right or pointing to the left? It's pointing to the left. Okay. In the top, the arrow is going the way of the pointy point on the inequality, right? The hungry alligator prefers 5 or whatever. I remember, was it hungry alligator or was it Pac-Man when you learned it? Hungry alligator? Yeah. There's always an alligator. This was always an alligator. The hungry alligator, like the bigger thing. But it's a little confusing in this next one. So if I'm not sure which way it's going to go, pick a number. Pick a number on one side of negative 6. Give me any number besides negative 6. Negative 5. Okay? So we pick negative 5. Is negative 6 less than or equal to negative 5? Would you rather be $6 in debt or $5 in debt? I'd rather be $5 in debt, right? That's better. I'm not as far into. So this is okay. This is true. Yay. Okay? So if you pick a number and it's good, that's the side you want to draw the arrow on. If I picked negative 10, I don't want to be in negative $10 in debt, so I don't want to shade that way. So I'm going to shade to the right on this one. Okay? When the X is on the right side, you actually are flipped around. Lauren, you were saying about the arrow pointing the same way as the inequality, but when the X is on the right, it's basically turned around. So you flip it too. Okay? Make sense? We flipped it around yesterday. If you flip an inequality, the inequality sign has to flip. So if I wanted to rewrite this, I could rewrite this as X is greater than or equal to negative 6. If I just flip the pancake, the inequality would flip as well. You see what I'm saying? And then it's like these ones up here. But they might not be all with the variable. Like yesterday, we had some where the variable is on the right side. It's almost more work to flip it. Okay? So what I'll do is I'll just pick a number. Here at 0, I'm going to put an open circle. And then I want to pick a number on either side of 0. Tristan picked negative 5. I generally stay away from negative numbers. I'm going to pick a nice positive number like 1 if I can, or 2. Is 1 bigger than 0? Yes. So if I tried like 0 less than 1, is that true? Yes. So if I pick this point right here and it's good, then I shade that sign. If I picked it and it's not good, I go away from it. I run away from that side and shade the other side. Okay? Okay. I'm not going to have a conniption about shading, but if it's pointing the wrong way, it's not totally correct, but you'll get practice at it. So I should have stuck with the crayon. I think the crayon's prettier. So okay, but that's something after you've done it. I'm going to ask you to graph it on the number line because it's a visual of all the numbers at work. Okay? All right. So how do we solve inequalities? Well, solving inequalities work just like yesterday when we were solving equations, except for the one twist. What's the one twist? When do you change the direction of the inequality? When you multiply or divide by a negative number. Okay? So if when we were dividing by 3 on both sides, we're cool. We leave everything be. But if we divide by -4 on both sides, then we have to reverse the inequality. Okay? So if I'm going to attack this like yesterday, we'll subtract the 5 first. Good deal. 2x is greater than or equal to 4. Thank you. Then divide by 2. Now when I'm divided by 2, I'm okay, right? We're not changing anything. Only with a negative number. So that would be x. Be like Paul McCartney and let it be. We have some of those a little bit later on. Okay? Okay? Yeah, so this is just like, that part's just like yesterday, right? We treat it like yesterday unless we're doing something by negative numbers. Okay? So if I were to graph this on a number line, if the number line's given to you, that's great. If it's not, do your best. Okay? Try draw a horizontal line. If you have OCD and you need a ruler, there's rulers over there. Guess what? There's 0, 1, 2. Is this going to be filled in or open? Filled in or open? Open. Or no, this is filled in because it's greater than or equal to. I'm sorry, I misheard you. I only got one ear. And I'm shading to the right. Okay? Because I want the numbers greater than -2, or the numbers bigger, and those are to the right. Okay? Groovy? How about, so here's one where we have a negative. So this is how it's going to go down. Subtract 5. -4x is greater than or equal to 32. And here's the red flag. Okay, because of the division by the negative. Okay? So x would be less than or equal to -8. Pretty easy peasy, right? You don't reverse it if you add or subtract. You don't reverse it if you add or multiply or divide by a positive number, only with a negative number. So if I were to graph this, there's 0. There's -8. I can count there and go to work. All right? So, you try this one. Oh, see, you should have been like writing all along. Is it hot and stuffy outside? I feel hot. It feels warm in here. Yeah. Yeah. I don't know what it. You all comfortable in here, or is it? I feel like my room's hot now, but then again, no. Anybody want to do this on the board? Somebody new and done one on the board? Want to try? You want to try it? Oh, okay. I thought you were raising your hand. You can do it at your seat. One person can do it at the board if they like. If not, that's cool. Yes, ma'am. You want to do it? Oh, you mean like Kahoot or something? We can do some of that. Yeah, we'll do some of that. We can do some of that. Ooh. I slid back. I almost felt like I was going to fall. You would have laughed at me, wouldn't you? Then you would have helped me up. Yeah, you would have laughed, and then you'd have been nice. Okay. Thanks. Yeah, I'm your grandma now, huh? At least I didn't get run over by a reindeer. What's your first step, guys? We got variables and numbers on both sides. Okay. We want to get all the numbers to one side and all the variables to another, right? Okay. So Gunnar suggested that we add 3. Is that fair? Okay, thank you, sir. Oops. And so I get 2x is less than 4x plus 8. Group. Okay, if I could subtract 2x, but then I have everything on one side. I need to get x's on one side and variables or numbers on the other. If I do that, I'm going to have to bring the 8 back over, right? You might still get there, but so Gunnar, you subtracted 4x. This is what my bud here in the front row is feeding me. All right, so -2. Oh no, So, okay, now we got to divide by -2. And this is the old flipperino. So what's my answer? X is greater than -4. Now, Lauren, you may have gotten that, the other way around, but if you get it flipped around, if you do it in a different order, you could get -4 is less than x. This is the other possible answer that I might see. Okay? If you got this by doing it the other way, bringing the x's over, that's fine. Okay? Why are those two equivalent is because the hungry alligator is choosing the x in both cases. That's how when I'm grading these, I'm looking for the way the hungry alligator is going. If he's both going in the same, to the same thing, the hungry alligator prefers the x in both cases. All right? So that's why they're equivalent. Yeah, we got to do the graph. You're right. I didn't finish. I'm not done. Thank you for reminding me. What's the graph going to look like? But wait, there's more. Not only do you get to solve the equation, you get the graph too. Oh. All right, I need an open circle, right? So, 1, 2, 3, 4. We're at -4, so I know I've got an open circle. Stay with me, guys. Now, if you get all of that, and you have the arrow pointing the wrong way, I'm not going to have a conniption, okay? But is 0, so I'm going to pick a number, one side. I might pick 0, because 0 is an easy number to work with. Is 0 bigger than -4? Yes, so my arrow would need to go. And Lauren was right. If your variable is on the left, the pointy point of the inequality is the same way the arrow is pointing. That's why I like with the variable on the left side too, because it makes it easier. I don't have to think about it as much. Okay, but that's what the graph would look like. Groovy? Got it? Nice. Okay, couple more. I mean, the worst thing I do is mix a bunch of stuff together and throw it all there. 2x minus 11 is less than negative 3x plus 2. What's the problem that you got to watch out for on this guy? You got to multiply that negative 3 through the parentheses. Okay? Well, you could do that, but then I have all kinds of ugly fractions on the other side. So I probably would do it. I mean, if I divided by 3, then I'd have 2/3, and I don't want to deal with fractions if I can avoid. I don't want to have fractions if I can avoid fractions. What happens when I run that negative 3 through there? What am I going to get on the right side? Negative 3x and negative 6. Take it from there. Run, my friends, run. Run, Forrest, run. Sorry. All right. No, maybe not. No. It's like 2.5 hours. I don't know. So, whatever. Okay. First step. What should I do first? You have an idea? What would you do? Okay, you're going to bring the 11 over. Okay. So add 11. Okay. Good deal. So 2x is less than negative 3x. What do I have on the right side now? You see, I'm having a little issue with that. I think, it's negative 6. And it wouldn't be plus 7, plus 5. It's negative 6. See the negative? When you did you multiply the negative 3? You might have written positive 6 there because you forgot to take the negative. A negative times a positive, okay? So, be careful. Now what? I got to get rid of this. How do I get rid of the negative 3x? I have to add 3x. $2x and 3x makes 5x. That's the extent of my magic. And that, I don't have to do the old flipperino. No flipping here, at least the way I did it. X is less than, Yes. Okay, that's fine. Did you get one? Did you get it? Yeah, you still got the same answer. That's fine. I am pretty mellow about that, as long as the math works out. What's the graph going to look like? Okay, open circle. Okay, so there's 0. Here's 1. Open circle, pointy that away. Okay. So the only thing that's really new is the graphing today and changing the inequality when you multiply or divide by a negative. Okay? So if you practice, we're able to solve equations. Now there is one other thing, I think, called compound inequalities. And this is what some of you might remember. I think Lauren remembered this a minute ago. Okay? And this is like the deal at Shoe Carnival. Buy one, get one half off. It's like you get to do almost 2 problems in one. It's even better because, it's math instead of shoes. Hey, ain't nobody got more shoes than me in this room, all right? Yeah, I have 38 pairs of boxed dress shoes. Like, oh, I'm like getting close to 50. Y'all are gonna laugh at me about this, okay, guys? I told you I live out in the country, right? So I live on a dirt road, and I have well, in the mornings I wear sneakers to school and put my shoes in a box, and then I get here, put my dress shoes on, so they don't get dirty. If I wore these at my house, they'd be all muddy and yucky. So after school, I'll take my shoes off, put my running shoes on, and carry my box shoes home. So, because I don't want all my dress shoes to get dirty, and I've got 38 pairs of dress shoes in boxes, and I just wear different ones. So, if you like colorful shoes, you're in the right class, and if not, then don't look down on my shoes. So, they're white today, yeah. I mean, what kind of guy has white shoes and matching belt? How many are you? Pick my shoe and then pick my shoes, and then everything else falls after that. So, shoes got to come first. Okay. All right. How is this like a 2-for-1 deal? Is you basically what we did to two sides? We had the two sides of the equation. Now we got like a three-headed equation. We got to do it to everything. What you do to one, instead of doing it to both sides, you do to all three. Okay? And it's going to be between some things. So I'm going to subtract 1 from all three parts. Okay? What is negative 3 minus 1? Negative 4. So I'm going to get negative 4 is less than 2x, less than or equal to, what's 3 minus 1? 2. So it's not that much harder. It's really just got three parts. And what you do to one, you got to do all three. Okay? And I want to get the x all by its lonesome in the middle, and I got to do it on both ends. Okay? It's still about keeping everything the same. Math is the only place where it's really, truly fair. So you can't discriminate against some part of the inequality. Okay? Maybe that's why I like being math. I like being fair. Okay? Well, not yet, because I got to get rid of the 2. I got to get rid of the 2, right? So how do I get rid of the 2? I got to divide by 2. And if I want to divide the middle part by 2 to be fair, I got to divide everything by 2. So I'm going to divide this by 2. Good job. You knew I wasn't done. Thank you. Negative 4 divided by 2 is negative 2. And negative 2 divided by 2 is 1. So what I want to do is I want to graph all the numbers between negative 2 and positive 1. Okay? Instead of the arrow going on forever, I'm going to mark my 2 endpoints and just shade in between them. So it's not that big a deal, right? So compound in the English language means joining, like compound sentences. You take two sentences and join them together. A compound inequality is like two inequalities merged together and had one problem. Okay? Same kind of thing. So if I put 0 here, 1, negative 1, negative 2. So what I would do is shade between negative 2 and positive 1. Since the one on negative 2 is an open circle, or is it less than, it's an open circle, and at 1, it's a greater than or equal, or less than or equal to, so it's shaded in. So I can shade one and open the other depending on the symbols, right? And then I would just color in between. Stay between the lines, or I'll get out my ruler and, make you sit in the wooden desk and wrap your knuckles like good old school church. No, okay. If they're going, then you would shade on the outsides. Yeah, okay? But don't make me wrap your knuckles. That's what that desk should be for. That should be like the desk of punishment. Shame, desk of shame. No, I won't. I don't believe in that. I don't believe in that, okay? So. Cool? And this is if you can have it be sandwiched in between two numbers, or you can have them spread out, go in the opposite directions, and that will look like this. So it'll have I can shade between, or I can have them going pointing out. And basically, a compound inequality is when you're doing two problems in one. Okay. So here I got to solve each one individually. Plus 5, plus 5. So 4x is less than 16. Divide by 4. X is less than 4. And then over here, minus 1, minus 1. Oops. All right, let me change this. Change that problem to that. So plus 1, 3x is greater than or equal to 21. X is greater than or equal to 7. So in this case, I'd have 4 and go off that way, and 7 and go off this way. Okay, so a compound inequality is basically when you have two problems on the same grid at the same time. They can overlap, or they can be in the middle, or they can be pointing out, and they'll usually be broken apart or joined together like they were in there. Okay? So that gives I'm sorry, I will do better. I took some of our time today, and we were on stats, so we lose 10 minutes. I promise you I'll give you a little bit of time, more time down the road, but these are also not the longest assignments. Actually, I guess this one's a little bit longer, but let me get you. Tomorrow we do not have stat, right? We're finally back to a normal, regular 90-minute schedule. So hopefully I'll have a little bit more time for you to practice tomorrow, okay? Get as far as you can today. If you don't finish this assignment, I'll give you a little bit more time at the beginning of class tomorrow, okay? But let's get as far as we can in the 15 minutes we got remaining, okay? Today's the 16th, right?